lesson 8 is investigating the graphs of polynomial functions, part 2. So this one looks at certain characteristics to be able to start sketching what our graphs look like without using a calculator. So if we look at the idea of repeated factors, the graph of the polynomial function p of x, which is x plus 1 times x minus 3 squared, is shown. There are two factors, one of which is repeated. So really, if I was to rewrite this, x plus 1, x minus 3, x minus 3. So in the previous lesson, we did learn that the number of factors equals the degree. This is a third degree polynomial. It does have 3 factors. It's just one of those factors is the same. So if I look at the graph, I have 2 zeros. 2 zeros because the 3 occurs twice. So if I look at this, we can say that the graph of the function has 2 different x-intercepts, which gives it 2 real distinct zeros. These are real numbers, and they're distinct, meaning that they're different from each other. So at -1, I have a real 0, and at 3, I have 2 real and equal zeros. At 3, we say we have a multiplicity of 2 because it occurs twice. And at -1, we have a multiplicity of 1. So if we look at the definition of a multiplicity, the multiplicity of the 0 refers to the number of times that the factor is repeated in the function. So what we're going to look at is we're going to see how the multiplicity of the 0 affects the shape of the graph. So we need to define a couple of terms. The first term that we need to define is a tangent. A tangent, a polynomial graph, is tangent to the axis to the x-axis at a point where it touches the x-axis but does not cross through it. So back when we were investigating geometry, the tangent to a line or the tangent to a circle is a line that touches the circle only in one spot but doesn't intersect the circle. So the tangent, if we're dealing with multiplicity, touches the x-axis but does not go through the x-axis. So it forms a parabola at the x-axis is really what it's doing. Then we have a point of inflection. A point of inflection changes concavity at the x-axis. So if I look here, I've got what seems to be kind of going on concave up because it looks like it should go up this way, but then it changes and goes down. So it goes from being a concave up to a concave down. Or in this one, concave up to a concave down, and it changes at the x-axis. So I have that point of inflection. At this point, we're only looking at polynomials that have a leading coefficient of a +1 or a -1. So we look at other leading coefficients in the last lesson, lesson 10. So let's look at an example. Consider the polynomial function p of x equals x to the power of 6 minus x to the power of 5 minus 11x to the power of 4 plus 13x cubed plus 26x minus 20x minus 24. This polynomial function, when it's factored, gives me x plus 3, x plus 1 squared, and x minus 2 cubed. What I want you to do is I want you to graph this using these window settings. And it would be easiest if you put this into your y1 rather than to the power of 6 to the power of 5. So use these window settings and then sketch the graph for me. So when I sketch this equation, what I have with my graphing calculator is I have this point, this part of the graph that comes straight through, and then it comes up, touches the x-axis, and then touches the x-axis again in a curved shape. yesterday in those questions, and then with question number 3, this is an even degree polynomial. And even degree polynomials, the right and the left arms always go in the same direction. So they either both go up or they both go down. They go up or down based on the leading coefficient. The leading coefficient was positive, so they're both going to go up. If the leading coefficient was negative, they both would have gone down. Then I've got these zeros. -3, -1, and +2. So it says, complete the chart below to state the zeros, the multiplicity, and whether the zero passes straight through the x-axis, is tangent to the x-axis, or has a point of inflection. So if I put our 3 zeros in numerical order, I have -3, -1, and 2. So the 0 at -3, if I look at the factor, what's the multiplicity of this factor? How many times is it repeated? Just once. What's the multiplicity of my x plus 1 factor?
2.
And my 0 of 2 has a multiplicity of 3. So my 0 of -3, if I look at the graph, does the graph go straight through? Is it tangent, or is it a point of inflection? At -3, what is it doing? Passing straight through. What happens at the 0 of -1? It's tangent to the x-axis. Because it didn't go through the x-axis. And what happens at my 0 of 2? It's the point of inflection. So at any 0, the graph is going to do one of those 3 things. It's either going to go straight through it, it's going to be tangent to it, or it's going to have an inflection to it. So you have to recognize those shapes. The point of inflection can be the trickiest one, because if your window settings are not set properly, it could be harder for you to see that curvature that it makes. But if I've got this factored, I should know with the multiplicity. The degree of this polynomial is 6. And if I add the multiplicities, I get 6. So the sum of the multiplicities will always equal the degree of the polynomial, which goes back to the previous lesson where the number of factors is equal to the degree. This has to have 6 factors, and it does if I was to write them all out. It doesn't have to have 6 zeros, so that's the difference. It has to have 6 factors, but not necessarily 6 zeros, because I can have a factor repeated. Okay, so let's look at class example number 2. Polynomial function has the equation x to the power of 4 plus 2x cubed minus 15x squared minus 32x minus 16. It's not factored for us, but what is one thing that you can tell me about this graph? Or a couple of things that you can tell me about the sketch before even drawing it. So tell me about the left and the right arm. What direction would they go in?
Rising, both of them.
Well, they'd both be rising because it's even and it's positive. Okay? Where would the y-intercept be? -16, because the y-intercept is the constant. So you've already given me 2 things about this graph without having graphed it, which is good because now when I put it into my calculator, if I did something wrong and I had like one end going up and one end going down, I know something was wrong. Or if my x-intercept was not down here, I would know something is wrong. So what I want you to do is use this window setting and sketch the graph. And you're going to need to identify the zeros of that graph. So there's the graph of my function, and again, I can see that both arms are going up, and I can see that the the y-intercept is below the x-axis in the negatives. So if I sketch this out, I get this picture that goes something like that. And we identified our zeros as being at -4, -1, and +4. So -4, -1, and +4. So at -4, what is the graph doing? Is it going straight through? Is it tangent? Or is it inflecting?
Straight through.
It's going straight through. And if it's going straight through, what is its multiplicity then? 1. Okay? At -1, straight through, tangent, or inflection? Tangent. And what's the multiplicity for tangent? 2. Without even looking at the graph, how could I figure out what the multiplicity of this one is?
It has to be the sum of the degree.
So the degree is,
4.
and I'm already up to 3, so this has to be,
1.
which means that the graph has to go straight through at 4. Does it go straight through at 4? Yes. So we've already actually answered these two questions, that the degree is 4 and the sum of the multiplicities also has to be equal to 4. So now if we were to write this in factored form, if I have a 0 of 4, what's my factor? Not x minus 4?
Oh.
If I, sorry,
I said -4.
if my 0 is -4, my factor would be x plus 4. And the way they have this written is the multiplicity of 2 is at the end. So then if I have a 0 of 4, the factor would be x minus 4. And then my 0 of -1 would be a factor of, and that's the multiplicity of 2, so it's squared. Okay? So the questions in this assignment, they're investigative questions to develop the relationship between the multiplicity and the graph. Because remember, our goal is to be able to graph these without using a calculator. So how could we do that? Well, if I didn't have a calculator, I can use the remainder theorem to start to develop factors. Then I could factor this out. Once I have this in factored form, I know multiplicities are 1, so it goes straight through. I know that this is a tangent, so I can draw that tangent. And I know the x-intercept is at -16. Whether or not you get these correct is not going to be the factor at this point in time. The factor is going to be, can I label these and label this and then join it together? Show that my arms both go up because it's even, because the leading coefficient is positive. So I've got that part. Show all the rest of it. Okay? So your questions